Okay, so now let's look at a system of nonlinear equations. So you can tell this is nonlinear because we've got an x squared in here. We could have x squared, y squared, we could have square roots. Remember, linear is just x and y with no exponent. So now we've got nonlinear. But the idea still works the same. You're going to do a substitution or an elimination. And when you look at the problem, you've got to decide which is going to work best. So for this one, since I have x and x squared, substitution or elimination is not going to be great for x. Substituting x and x squared is doable, but this is going to become a mess. But we see these y's right here. We could do substitution or elimination with these, and it would work just fine. So we see y and y, and we think, okay, that's a good candidate right there. So the biggest part of these is deciding how you're going to tackle it. And sometimes you tackle it one way, and it's just not working out. You can go back and do a different way. So if substitution doesn't work, don't be afraid to go back and try elimination or vice versa. So this one looks like it's already set up for substitution. We're already solved for y. So we could just go ahead and take this and substitute it into the other equation. Okay, so let's do this one by substitution. So we're going to replace y with x minus 1. We're going to get x minus 1 is equal to x squared minus 6x plus 9. So the substitution works exactly the same. The big difference here is that because it's nonlinear, you could end up with something that's nonlinear here in this equation. So when we look at this and we see this x squared here, we think, okay, this is a quadratic. This goes back to section 2, and we have to decide how to solve this. Pretty much all of these are going to solve by factoring pretty easily. So if you get down to something that's very difficult to solve, you probably did the first step wrong. So let's move everything to one side. We'll subtract x, and we'll add 1. Let's get everything to one side, and we should be able to factor. So we've got x squared minus 7x plus 10. So we need factors of 10 that add up to negative 7. So negative 5 and negative 2 should work. Let's test it out. So negative 5 times negative 2 is positive 10, and if we add them together we get negative 7, so those are our two factors. We've got something times something equals 0, so we can break it up. X minus 5 equals 0, and x minus 2 equals 0, and we get positive 5 for one solution, and positive 2 for the other solution. Okay, remember our solutions are intersection points. So for each x, you need a y, and vice versa. So now we plug these back in just like we did before, but we're going to have to do it twice because we've got two different values of x. So we're going to plug in x equals 5, and we're also going to plug in x equals 2. Okay, so plugging in x equals 5, this first equation definitely looks the easiest. Y equals 5 minus 1 equals 4. So when x is 5, y is 4. Now one thing that is different here, and this is super important, is that you have to check. You have to check these answers. You can do everything perfectly right and get down to a false answer, an answer that does not work in both equations. So you must remember in this section to check. It's not just a good practice, you have to do it. So since we use the first equation to solve, we'll use the second equation to check. You can check them in both, but you just need to at least check them in the other one. So plugging this into the second equation, we're going to get 4 is equal to 5 squared minus 6 times 5 plus 9. So that's 25 minus 30 plus 9. So we're going to get negative 5 plus 9. And that is definitely 4. So that one checks, and we can go ahead and keep that answer. Okay, let's do the same exact thing for 2. We're going to get y is equal to 2 minus 1 equals 1. That's an equal, not a minus. So we get the point 2 positive 1. And let's check it. We used the first equation to solve, so we'll use the second equation to check. So we get 1 is equal to 2 squared minus 6 times 2 plus 9. So 1 is equal to 4 minus 12 plus 9. And we get 1 is equal to 1. And so that does check, and we can keep that answer. If one of the answers did not check out, we would throw that one out. If both of the answers did not check, that's a red flag that you did something wrong and you need to go back and check your work, because you should, if there's two answers, you should save at least one of them. Okay, so that's the idea for nonlinear equations. Let's go ahead and try one more together. So this one we did substitution. Let's do one with elimination. Let's do x squared plus y squared equals 16, and x squared minus 2y equals 8. Okay, so definitely another system of nonlinear. We see those x squareds and y squareds. And for this one, we're looking, do we want to do substitution or elimination? Well, we've got x squared and x squared, so we could do substitution or elimination there. Whoops, didn't want to write over that. Either one would be fine there. We've got y's over here, but y squared and y, they're not going to eliminate. We cannot combine y squared and y, so we cannot do elimination here. And not great for substitution. This is a better option. So let's look at the x squareds. Since we just did substitution, let's do elimination on this one. So let's take the, doesn't really matter, let's take the second equation and multiply through by a negative. Okay, because we've got x squared here and x squared here. We need one of them to be negative so that they cancel out. So our equations are going to become x squared plus y squared equals 16. We didn't change the first one. The second one's going to be negative x squared plus 2y equals negative 8. Remember to change all of the signs. So now when we combine them, the x squareds cancel out, which is what we want. We've got y squared plus 2y. Those don't combine. So we just got y squared plus 2y equals 8. Okay, so we did our elimination, and what do we have? Again, we have a quadratic. Let's move everything to one side, and we should be able to factor. So we're going to have y squared plus 2y minus 8 equals 0. Factors of 8 that add up to 2 should be plus 4 and minus 2. So we multiply them, we get negative 8. We add them, we get positive 2. We've got something times something equals 0. So we know that we can break this up by the zero product rule. And we get negative 4 and we get positive 2 when we solve those. Okay, so negative 4 and positive 2. And we need to go back and plug those back in. So we're going to plug in negative 4 and check. And we're going to plug in positive 2 and check. All right, it doesn't matter which one you want to plug these into. We can use the first equation. So we've got x squared plus negative 4 squared equals 16. So we're going to get x squared plus 16 equals 16. So we subtract 16 from each side. We get x squared is equal to 0. Remember, anytime you have something squared is equal to a number, you can take the square root on both sides. And we should remember our plus or minus, but for this one it's not going to matter. So the square and the square root cancel on the left, and the square root of 0 is just 0. So for this one we get the solution of 0, negative 4. And remember, we have to check that. So we use the first equation to solve. Let's use the second equation to check. So we're going to have 0 squared minus 2 times negative 4 is equal to positive 8. So we've got 0 plus 8 is equal to 8. That checks out. And we are going to save that solution. All right, moving on to the next one. Sorry, this is a little bit tight here. Let's draw a line here so we don't get confused. Okay, so plugging in the positive 2, we're going to have x squared plus 2 squared is equal to 16. So we've got x squared plus 4 is equal to 16. Subtract 4 on each side. We've got x squared is equal to 12. Same thing, we take the square root on both sides. And we get x is equal to plus or minus the square root of 12. All right, that does reduce, but you remember, for me, you don't need to. So for this one, we actually get 2 points. We get, sorry, I did that backwards. We get square root of 12, 2, and we get negative square root of 12, 2. And we need to check both of them. I'm going to come over here for the checking part. Okay, so we need to check square root of 12, 2. In the second equation. We use the first equation to solve, we use the second equation to check. So when I plug that in, I'm going to get the square root of 12 squared minus 2 times 2, and I need that to be equal to 8. So the square root of 12 squared, those are going to cancel out. We get 12 minus 4 is equal to 8. So it looked a little difficult to start, but it actually came down to something pretty simple. And we see that it does check, and we are going to keep that solution. Okay, checking the other one, negative square root of 12 too. So we're going to have negative square root of 12 squared minus 2 times 2 equals 8. So negative squared is going to come out positive, and again, square root of 12 times square root of 12 is positive 12. So again, we get 12 minus 4 is equal to 8, and that one does check out as well. So we actually keep all three of these solutions. We've got one here, 0, negative 4. We've got one here, negative square root of 12, 2, and one here, positive square root of 12, 2. So we've got three solutions for this one.